Okay, so let's actually try this again. Let's go ahead and go over those practice problems for our moles review. Okay, so number one, we have what is the mass of 4 moles of oxygen gas. Okay, so remember, our first step is always to identify, well, what's your given? Okay, wherever your number is, that's going to be your given. So we have 4 moles of oxygen gas. That's going to be our given. And what are we trying to find? We are trying to find mass. Okay, so now that we know what's our given and what we're trying to find, we're going to go ahead and take a look at our mole map. Okay, so we can figure out, is this going to be a single step or is this a multi-step? Okay, so in this case, we were given moles of oxygen. So that means we're right here on our map. We're at moles. So we're looking for mass. So that means we have one conversion factor. So it's going to be a single step problem. Okay, so remember that our general formula is going to be given times what we're trying to find over same unit as our given. Okay, so if our given is 4 moles of oxygen, we're going to go ahead and write that down. 4 moles of oxygen. Now remember, oxygen is a diatomic, so you are going to need a subscript of 2 for that oxygen. Okay, and then we're going to multiply that by our conversion factor. Now remember, we said our conversion factor is right here. 1 mole equals molar mass. Well, if it's molar mass, then I'm going to have to calculate our molar mass. So off to the side, molar mass for oxygen. Okay, well, that means we're going to have to take a look at our periodic table. So let me pull that up. Our periodic table tells us that oxygen has a mass of 15.999. Okay, so my atomic mass for oxygen is 15.99, and I have 2 of them. Okay, so 15.999 times 2. Okay, let's take a look at our calculator. 15.999 times 2. That equals 31.998 grams. Okay, so since that's our molar mass, then we know what our molar mass is. Okay, so back to our conversion factor, which is right here. So our conversion factor is 1 mole equals molar mass. So remember, what goes on bottom needs to be the same unit as our given. So if we were given moles of oxygen, then we know that our 1 mole goes on bottom. So 1 mole of oxygen. And then our molar mass is the one that's going to go on top because that's what we're trying to find. So molar mass is 31.998 grams of O2. Okay, so before we solve, we can take a look at, is there any units that cancel out? Okay, so moles of oxygen divided by moles of oxygen, well, they're going to cancel each other out. So what we're left with is 4 times 31.998 grams of oxygen. Okay, so again, let's take a look at our calculator. We have 4 times 31.998, which equals 127.992. Okay, but remember, this is science. We need significant figures and units, so we're not done yet. Okay, so in our problem, we were given 4.00. That is 3 significant figures. So these are my first, second, and third significant figures. So that means the rest I can just ignore. Okay, so that 9 is going to round that 7 up to 128 grams of oxygen. So remember, whatever unit you have for your answer should be the same unit as what you're trying to find, grams of oxygen. Okay, and that'll be our final answer. Now remember, for your quiz for this unit, we check everything. We're going to check your number value. We're going to check your unit. Do you have the right unit? Do you have the right element? Okay, because if you don't, then it's going to be wrong. Okay, we are going to be very particular with values and units in this unit. Okay, so you have been warned. Okay, so number two. Number 2, what is the volume of 3.4 times 10 to the 25th molecules of CH4 at STP? So first step is to identify what's been given, and what's been given is 3.4 times 10 to the 25th molecules of CH4. Okay, and what am I trying to find? I am trying to find volume. Okay, so on my my mole map, let's try to figure out where I am. Okay, I was given molecules. So remember that molecules, well, it's not grams and it's not liters, so it must be particles. Okay, remember that particles are atoms, molecules, formula units. Okay, those are representative particles. So molecules, I would start here, and I've been asked to find volume. Okay, so take a look. We pass through 1 conversion factor, 2 conversion factors. So that means this is actually a multi-step problem. Okay, so first step is always to write what's been given, and you have been given 3.4 times 10 to the 25th molecules of CH4. Okay, and then again, we said that there's already 2 conversion factors. Okay, so your first conversion factor, we start at particles, so our first conversion factor is 1 mole equals 6.02 times 10 to the 23rd particles. Okay, so how do you know what goes on top? Which one goes on bottom? Well, remember, if this is molecules, then the one below it, or the one on bottom, should also be molecules. So 6.02 times 10 to the 23rd molecules of CH4. So what would go on top would be our 1 mole of CH4. Okay, that's our first conversion factor. Our second conversion factor would be this one right here. 1 mole equals 22.4 liters. Okay, so again, which one goes on top, which one goes on bottom? Well, if this is 1 mole of CH4, then on bottom should also be 1 mole of CH4. Okay, so our 22.4 liters would be the one that goes on top. And then make sure that's correct. Is liters what you're trying to find? And yeah, we are trying to look for liters. Okay, so before we solve, we can go ahead and cancel out our units. So molecules of CH4 is going to cancel out molecules of CH4. Okay, your units cancel out. Our 1 mole of CH4 cancels out our 1 mole of CH4. So what we're left with is actually 3.4 times 10 to the 25th divided by 6.02 times 10 to the 23rd times 22.4 liters of CH4. Okay, you don't have to go in order. I know some of you guys like to multiply first, so you guys would multiply 3.4 times 10 to the 25th times 22.4, and then later on divide by 6.02. It doesn't really matter what order, okay, because it's just multiplication and division, so it doesn't really matter. Okay, so if you want to try to figure this out on your own, I do recommend that, because calculating scientific notations in your calculator is a bit of a problem for you guys. So go ahead and pause the video, pull out a calculator, try to calculate this on your own. But I will go ahead and show you guys how to use your calculator. Okay. Let's see. Okay, so I'll just go ahead and work out the problem for you. Okay, so on your calculator, we have, let me zoom out just a bit so you guys can see. Okay, so we have, okay, so remember, whenever you're using a scientific notation number in your calculator, you must put that number into parentheses. So 3.4 times 10 to the 25th power. Okay, and then with that, I'm going to divide by another number, so that needs to be in parentheses, 6.02 times 10 to the 23rd. Okay, and then I'm going to go ahead and push enter. Okay, I like doing one step at a time. So enter, and then that needs to be multiplied by 22.4. So times 22.4. Okay, and so our answer is 1,265.12. Okay, but if we take a look at our problem, scientific notation, how many significant figures we have? We have 2 significant figures. So here is our first significant figure, our second significant figure. So that means our 6 is going to bump that 2 up. Okay, to a 3. And then remember, if you have 1,000 whatever, the rest of your numbers can become zeros. So now you only have 2 significant figures. And then don't forget, our unit is what we're always trying to look for. So it's going to be liters of CH4. So liters of CH4. Okay, so that concludes our notes for today. If you guys have any questions, please, please, please ask. Okay, the unit is only going to get harder from here if you don't understand how to do dimensional analysis. Okay, so again, this concludes our notes. Please ask if you have any questions.